Good morning, students.
Good morning, ma'am.
Today we are going to study about how elements can be classified into metals and non-metals based on their physical properties. In class 9th, you have studied about how various elements are present in our nature. Now, can you tell me what are the elements which are present in the classroom? Yes, Ankit?
Ma'am, carbon, hydrogen, oxygen present in atmosphere.
Very good. Anyone else?
Bench is made of iron, wood and aluminium.
Very good. Can you classify these elements into metals and non-metals? Yes, Rahul?
Iron, aluminium are metal, wood is non-metal.
Very good. How do you distinguish that they are metals? Yes, Ankita?
Iron and aluminium are hard, whereas oxygen and hydrogen are gases.
Very good. So now we are going to learn how to classify elements into metals and non-metals based on their physical properties. Let us start with metals. The first physical property that we are going to discuss is the luster. We all know that metals have a luster. Let us see this with an activity. We can take a few examples of magnesium wire, copper wire and an iron wire. Now when we see this, we will see that it is slightly dull. We will clean it with a sandpaper and we will see that it has a luster. So metals in their original state are having luster, but when they react with the atmospheric gases, they become dull. Next physical property is metals are hard. Now we can do this with an activity. We will take a copper wire and an aluminium wire and try to cut it with a knife. We will not be able to cut it because they are very hard. But now if we take a sodium metal piece carefully with the help of tongs and dry it between the folds of the filter paper and keep it in a small glass dish and cut it with a knife, we will see that it will cut easily. So sodium and potassium are two exceptions in the metals as they can be easily cut with the knife, they are not hard. Another property of metals is malleability. If we take a small piece of copper or iron and put it on a block of iron and try to hit it with a hammer 4 or 5 times, we will see that the small piece of copper will change its shape. So this property of metals to convert into sheets on being beaten is known as malleability. Now let us understand the use. Why are gold and silver metals used for ornaments? Can anyone tell me? Yes, Ankit?
Because they have shine and can be given any shape.
Yes. So gold is the most ductile metal and you will be surprised to know that 1 gram of gold can be drawn into a wire 2 kilometers long. So gold ornaments can be given shape according to which property of the metals? Yes, Ankita?
Ductility and malleability.
Very good. So because of the ductile and the malleable nature of metals, they are used to make the ornaments. And silver and gold are used because they do not react with the atmosphere easily. We come to the next property, which is the thermal conductivity. For this, we will do a small activity as shown. We will take a small wire of copper or aluminium, fix it on the clamp as shown, and on the free end, we will fix a small pin with the help of wax. On the other end of the clamp, we will light a burner and allow the metal to heat. We will see that after some time, the pin falls down because the wax melts. This shows that the metal has passed the heat. So this shows the thermal conductivity of metals. If we allow the heating to continue for a very long time, nothing will happen to the metal. So this shows that metals have very high melting points. The next physical property of metals is electrical conductivity. Here we will set up the apparatus as shown, and between the clamp A and B, we will put a metal wire. It can be copper or aluminium. When we complete the circuit and switch it on, we will see that the bulb glows. This shows that the metals have allowed electricity to pass through it. How does a metal allow electricity to pass through it? This flow of current is because of the free electrons in the metal. Silver is the best conductor of electricity, but we don't use silver to make wires because it is very expensive. We use copper and aluminium to make electric wires. Yes, Rahul?
Why do electric wire have plastic covering?
Very good question. Electric wires have a plastic covering made up of polyvinyl chloride or PVC. This is a good insulator, so if we accidentally touch the wire while electric current is passing through it, we will not get a shock. I hope you have understood that. Now we go to the next property of metals. Tell me, in our school, why do we have a bell made up of metal and not wood? Yes?
Ma'am, because it produces sound on getting struck.
Very good. This property of metals is known as sonority. That is, the metals are sonorous. When they are struck, they give a resounding sound. Another physical property of metal is that they have high tensile strength. What does that mean? That means that metals have a great capacity to bear load. Metals are also, we have seen, solid in nature, excepting mercury, which is liquid at room temperature. Now let us see the practical uses of metals. Metals like aluminium and copper are used to form foil, which is known as aluminium foil, and it is used for packaging as well as it is used at home. We also use metals in bridges and for the construction purposes because metals have a very high tensile strength, that is the load bearing strength. These are the practical uses of metals. Now we start with the non-metals. Give me some examples of non-metals. Yes, Dinesh?
Ma'am, carbon, oxygen, iodine.
How are they different from metals? Yes?
Ma'am, they do not have the same physical properties.
All right, so let us study about the physical properties of non-metals. One, they don't have luster excepting iodine. They are soft and brittle. Exception is diamond. Diamond is an allotrope of carbon, which is the hardest substance found in nature. They are not malleable. They are not ductile. Non-metals are poor conductors of electricity. Exception is graphite, which is an allotrope of carbon. Non-metals are not sonorous. They have low melting and boiling point, excepting diamond and graphite. They have low tensile strength. Mainly, non-metals are found as gas or solid. Exception is bromine, which is found as a liquid. Let us see the uses of non-metals. Non-metals like carbon, hydrogen and oxygen are present in food components like fats, carbohydrates and proteins. Nitrogens are used in various fertilizers. When we divide elements on the basis of their physical properties, there are many exceptions. So we will discuss a few of the exceptions now. Generally, metals are very hard, where exceptions are sodium and potassium, which are soft metals. Metals have high melting and boiling points. The exceptions over here are cesium and gallium. They can melt on the palm of our hand. Their melting point is so low. Metals are generally solid. The exception over here is mercury, which is a liquid at room temperature. In non-metals also we see certain exceptions. Like for example, carbon, which is a non-metal, exists in many forms which are known as its allotrope. Graphite is one of its forms and it is a good conductor of electricity, whereas non-metals are poor conductors of electricity. Non-metals generally do not have a luster, with the exception of iodine, which has a luster. Carbon is a non-metal, but it exists in many allotrophic forms like graphite and diamond. Generally, non-metals are soft, but diamond, which is an allotroph of carbon, is the hardest substance present in nature. Another allotroph of carbon, known as graphite, is a good conductor of electricity, whereas non-metals are poor conductors of electricity. So we see that physical properties cannot be used to differentiate between metals and non-metals accurately. We will now discuss in the next module how chemical properties can be used to distinguish between metals and non-metals. With this, we come to an end of this module. I hope you have enjoyed it. Thank you, students.
Thank you, ma'am.
In this module, we have learned that elements can be classified as metals, non-metals. Physical properties of metals. They possess luster. They are generally hard except sodium and potassium. They are malleable. They are ductile. They are good conductors of heat and possess high melting point. They are good conductor of electricity. They are sonorous. They possess high tensile strength. They exist in solid state except mercury. Physical properties of non-metals. They do not possess luster except iodine. They are soft and brittle except diamond. They are non-malleable, cannot be beaten into thin sheets. They are non-ductile, cannot be drawn into wires. They are poor conductor of electricity except graphite. They are non-sonorous. They generally have low melting and boiling point except diamond and graphite. They have low tensile strength. They generally exist in solid or gaseous state except bromine, which is a liquid. Before moving on to the next video, you have to answer the following questions correctly. Question 1. Only non-metal which exists in liquid state: A. Iodine, B. Hydrogen, C. Bromine, D. None of these. Question 2. Aluminium foils can be prepared due to which property? A. Malleability, B. Ductility, C. Sonority, D. Conductivity. Question 3. The hardest substance known is diamond, which is A. Metal, B. Non-metal, C. Metalloid, D. None of the above.